So today I want to talk about cancer strategy. Currently, what is used now as a strategy for cancer is, from my viewpoint, not really a strategy. Using chemo and radiation to kill cancer, yes, it may work, but at the same time, it also kills off your own immune system, right? So a strategy is some type of leverage that you're using your resources in a clever way to overcome a problem. Not necessarily give you a bigger problem, right? Because what good is killing cancer off if it also kills the rest of the body off? So from my viewpoint, we got to come up with a better strategy. What do we know about cancer? We know that cancer starts in the mitochondria. Some type of mitochondrial damage occurs where the normal cells start to transition into a cancer cell. And we know this transition is like a survival mechanism because the metabolism of a cancer cell is different than a normal cell. Normal cells use respiration as their metabolism. And the simple way to understand respiration is with oxygen. Okay, so they need oxygen to make their ATP or fuel. A cancer cell doesn't use respiration. It ferments its fuel. And the simple way to look at fermentation is without oxygen. And so that's the main difference between a normal cell and cancer cells. Now there's some other differences too. With a cancer cell, it becomes immortal. And that's another big difference. Okay, they live forever and they start rapidly dividing faster than normal cells. And so that's a difference. And it's important when you're evaluating strategies to understand differences between things, okay? Normal cells, cancer cells, because then we can come up with a potential solution. And one solution is to starve off the cancer, okay? So what do we know about cancer? What type of fuel does cancer survive on? Well, we know it can live on carbohydrates, glucose, right? Because the way that they can diagnose cancer with a PET scan is areas of your body where there's a high metabolism of glucose, okay? So we can avoid sugar and carbs, right? That's not that hard. But also cancer can live on certain proteins. So we can lower the carbohydrates in our diet, and we can lower our proteins. But now the question is, can cancer actually live off fats and ketones? And unfortunately, yes, they can. Now it's taken me quite a while to agree with that point because I was operating off of this idea for many years that cancer cells can't live on ketones. But I will share some research with you with some links down below that will show you, unfortunately, that cancer cells actually depend on ketones. And this is a big problem, especially with people that are researching things, fixed ideas. When you have a fixed idea and you're holding on to this one viewpoint, and if you're not flexible in your thinking, you're not always going to be successful. So this gives us another problem. How are we going to survive on a low carb, low protein, and low fat diet? What's left? Well, we can fast, okay? We can consume plants that are loaded with phytonutrients that are anti-cancer. Well, that's great. But what if the person is too thin? What if the person is older and thin and fragile and they need certain calories? What if the person just does not have the discipline to do fasting for a week at a time or a month at a time? So that gives us another problem. And what are we going to do? Well, there is something you can do, and it really has to do with more understanding of the differences between normal cells and cancer cells. And that's what I want to share with you right now. Okay, so cancer cells compared to normal cells. There is something that's very, very unique that we can take advantage of, okay? And this has to do with how a cancer cell makes a cancer cell's membrane. Comes from a certain compound, okay, called acetyl-CoA. And the only source of this compound that makes a cancer membranes comes from ketones. With normal cells, the cell membranes can be made from other types of fuel sources and materials. But with a cancer cell, only ketones can provide this intermediate material. So you can kind of look at it like this. There are three enzymes or pathways or doors that provide this material to make these cellular membranes and provide fuel. Okay. With normal cells, they can use all three of these doors. With cancer cells, they can only use this one door. And the name of this door, and I've given you the long name and the short name. We're just going to stick with the short name. It's called SCOT. Okay, this is an enzyme. It's a pathway. It's a door. And if this door is open, then the cancer cells can make its membranes and survive and thrive. If this door is shut closed, it can't. So there are certain drugs that are SCOT inhibitors that will help kill cancer, okay, and stop it from growing. But they have side effects. But there are also natural SCOT inhibitors that potentially can work. And in certain studies, they show that it does work. So what we're doing right now is some actual research on this using credible scientists, using a credible study. It's a double-blinded study using various SCOT inhibitors to really prove this theory. Now, we're not just going to do one study. We're going to do multiple studies over a period of time to really, really figure this out. So out of all the data that I've studied, this so far seems to be the most promising because, number one, this would allow someone to try something that's non-toxic. Number two, a person wouldn't necessarily have to do the very, very strict fasting that would be required to try to get rid of this cancer. So in future videos, I will be sharing with you the results. But in the meantime, I'd really appreciate your help with this research in the form of a donation. But it could be anything that you can afford. The more people that can help, the better. And I'll put a link down below of a nonprofit organization that you can donate using PayPal. And for those of you that are willing to donate anything, I'm going to share with you the diet that I would recommend in association with the protocols, the SCOT inhibitors and various other things that we're using in this research. Here's the problem. 40% of the population is going to come down with cancer. And it might not be you, but it's definitely going to be someone that's close to you. It could be a family member, a friend, a relative, your own spouse. So we really need to come up with a non-toxic, real strategy that can help you. So please donate what you can. I put the links down below. Stay tuned for more videos on this topic. Hey, before you go, if you're benefiting from any of my content, I would love to hear about your success story. Please share it in the link down below.